All right, everyone, April the 10th. All right, let's get this one. I got an easy one today. To determine whether it's valid. Stack, right? It's an old problem. Right, let's do stack. Right, so we put in a stack, and every time it's a left, we'll push into the stack. If it's a right, then we will pop from the stack, right? And when we pop, it has to match. So we get a stack, right? And then we say for letter in S. If letter is in, let's say, oh, we can actually do, it's fine. It's in left, right? And this, and this, right? Then we say stack.append left letter. If letter is equal to this, okay, so right, then if stack and stack this is equal to a left, right, then we will say stack.pop. Oh, stack.pop. Otherwise, we'll return false. And then we'll basically do exactly the same thing. This and this. And we will do this. Right, and this will be a bracket. This will be a bracket. If everything done, we'll return true. Can we make this? I think we can. We can make it. For example, we can do a paren. Let's say we do, what do we do? A right will point to a left. Okay. Maybe we can do it in one line. And this pointing to this, right? And this pointing to this. Now here we can say, can we say paren.values? I'm not sure, but I guess we can, right? Else, right? Elif stack and stack -1 is equal to paren letter, right? If that's the case, then stack.pop. Else return false. And now we don't need any of this. All right. I have confidence. Let's just try directly. Okay. S is the length. Let's try to say this. Okay. Let's try this. Let's try. That should be good enough. Hey, we got it wrong. Which one is wrong? True, false. I have a true. Which one? Left by itself. Dude, left by itself. Shall return. We say len stack is equal to 0. Because at the end I'll have to pop everything. There you go. That shall work. Oh, look at the history of this problem. I've done it many, many times. Okay, nothing more to say. I'm curious, how did I solve it last time? When the first time we solved is 2018. Wow. Yeah, I still remember back then I tried to solve every problem using 2 different languages, and then I gave up. Just take too much time. And then 2021. And then 2022. I wonder how I solved it last time. And now 2023. Yeah, it's old problem. Good. I think this is actually, I would actually categorize this as a like a medium low, right? An easy medium. If it's the first time you ever encounter this problem, it's not that intuitive, right? It's not that intuitive. Wait, I was trying to copy this one. 28. It's not intuitive at all. Okay, this is the old solution. Okay, this is better. I actually like this one better. This, okay, okay, we can do that too. That's fine. Okay. All right, so we've done this. Now we can go to the last page. Actually, not last page. We have to do this 1, 2, 3, 4. Let's see how many can we do today. Don't know. Maximum difference by remapping a digit. You give an integer num. You know that. Huh? What the hell is this guy? I think it's someone working. Is that someone working for LeetCode? Oh, wait, no. Competitive Programming Hall of Fame. Holy crap. Who is this dude? Didn't give me any. Danny Mattal. Okay. We'll sneakily remap one of the 10 possible digits to another one. Return the difference between the maximum minimum values Danny can make by remapping exactly one digit. The difference between the maximum and the minimum value Danny can make by remapping exactly one digit. What are you talking about? If you can remap only one digit, you want to make it bigger, so you'll remap the first one, make it the largest. If you want to make it smaller, you'll remap the first one to make it largest, right? Yeah, you map the first digit 1 to make it 9, so you get, oh, hold on. You remap everything. I'm wrong. Everything. But it still doesn't matter. You still want to remap the first one. So yeah, 99891. Otherwise, you remap 1 to 0 and become 890. And then the difference, if it's 90, that is going to be, oh, it's interesting. You cannot just remap here. You have to map. Of course, if the first one is 9, you don't map the first one, you map the second. All right, and then to map to 0, yeah, you always map the first one to 0. That is true. So that's why it's 99. It was actually an interesting question. I think it's quite interesting. So I think I will do it, the same way, right? The same way as how you would do it. You will go from num. We're gonna do a str num. We're gonna do str num, and then we go from the front and find the first one that's not 9, and then we say, well, turn that one, right? How do you find the first one that's not 9? So we can say, I just want to index the first one that's not 9. Yeah, I guess that's the only way, right? I hate this. If num stri is not equal to 9, then we will break. Otherwise, I plus equal 1. I don't like it. I don't like it for I in range. Let's do it for I in range. For I n letter in enumerate num_str. Let's do this. If letter is not equal to 9, right? Then I break. Then letter. We already have letter. I just need to replace letter. So I probably don't even need to enumerate. I just go through the whole thing. All right, and we break. Then we can say max num equals to num_str dot replace letter with 9. And we will int this thing. Right, minimum num equals int num_str dot replace whichever is the first one. We'll replace that with 0. And then we'll return max minus minimum. Oh. Okay. Take a look. Okay. I want to. Yeah, sure. Whoa. 10 to the 8. 1, 2, 3, 4, 5, 6, 7, 8. Well, that's too much. 1, 2, 3, 4, 5, 6, 7, 8. Okay. No, that's still too much. That should be good. Okay. Can we submit? No, I have to wait. Okay, now I can submit. Yeah, nothing to say too much. Find the first non-9 digit and swap all of its appearances with 9. And then swap this gives us the max, and swap the first digit with 0. Not the first, all occurrences, right, of the first digit with 0. That gives us the main, right? We call it on, but it's fine, doesn't really matter. Okay, this one's done. We'll move on. Minimum score by changing 2 elements. You're given an array, okay? The low score is the minimum value of this minus this over all of them. The high score is the maximum value of this minus this over all. The score of num is the sum. Dude, the sum of the high and the low scores. To minimize the score, we can change the value of most 2 elements in nums. Return the minimum. Talking about the amount of twists, right? The amount of twists. Return the minimum possible score after changing the value of a most. So we have a score to begin with, which you can get by just sort it. Right? You sort it, and then you do a sliding window, so you get a low, and then the minimum and the highest value, that's the difference to give you the high, and you add them together, right? And it's telling me that we can, now it's asking me to change at most 2 values. Yeah, we just think about 2 values, it's okay. We can, like if we only need to change 1 value, or we don't change any value, we can just change it to the same value, right? So it doesn't really matter. So for this one, right, to begin with, we can say, okay, 1, 4, 3, what does that mean? That means 1, 3, 4, right? And the low score is going to be 1 because 3 and 4. And the high score is going to be 3 because 1 and 4. And the the sum is going to be, but what are you changing? Changing the value of nums1 and nums2. Oh yeah, that's for sure. So now the sum is going to be 4. Then we want to know, by changing two values, can we get the score lower? Which we can do by changing both 3 and 4 to 1. Then the low and high is 0, and the in between is 0. Now this is to find the minimum possible score. So the first thing, okay, the first thing in my head is binary search, right? Binary search. You can binary search. Like we say, is it possible for the but hold on, binary search, you would have to know like what value to change. Maybe not. Let's keep looking. Second example, 14785. Okay, and we want to minimize the sum, so we want to make two values the same, right? Make two values the same. If we have two values that are the same, then the low score will always be 0. That's a good observation. So sum of 14578, right? So it doesn't really matter. We can just pick any one of the value, turn them into the same as another one. So boom, low is resolved. Now we just need to make the high smaller. Now how to make the high smaller? Now to make the high smaller, let's say now the current high is lowered. Now we cannot make the high smaller. We can make the low bigger. We turn 1 into 4, and we turn 8 into 7. That's it. Then the low is 0, the high is 3. I mean, it gives you a different, but I think that is solution, right? You sort the numbers, you sort them from low to high, and you just increase the minimum, decrease the maximum. Yeah, I think that's the solution. You don't even have to sort. I just need to find the minimum and maximum, and that shall work. I think. All right, let's try this. So we will do we'll do this. We say, oh, we have to sort. We have to sort. And after sort, all we need to do is what? Minimum is 3. Oh, yeah, it's perfect. So we shall return nums second largest minus 2, right? Minus nums second smallest. I think that's it. I seriously think that's it. All right, these definitely will work, but let's try my way of creating test cases. Very silly though. It's not right. All right, that's interesting. That is very interesting. So my idea does not work. Okay, now we have to test it. I thought this one will work. Huh. What do you know? Does not work. Expect 653. Good. That means we misunderstood. Right? Alright, let's see. Print nums. So what I say is, oh shoot, we already have it. Well, for one, we just need to bring this one down, right? And how do we oh, that is true, because I have already get the low, so we don't have to move the low. Darn. Right? You don't have to move the low, so you can move the high. Just oh. Okay. Then it's just this one. Right? 653. Yes. But what if this side is also good? Well, you either move both. Oh, it's actually not that. Okay, so if we don't have, right, then we just need to move this one, done. If we have one side, then we just need to move the other side. We move to this one, right? Make these both equal to this one. If we have this is the same, do we move on here? That's a good question. I think it depends. Because each move will tell you how much we can reduce, right? Therefore, yeah, you have to decide which side will be, like, even if, yeah, I just realized something. If I have something like this, right? Let's say we have 1, 2, 3, and I have 1,000. No, I have 10 and a 1,000. And, I don't know, 10,000. What would you do? I shall get to 10, and that will give me 9. Right? I think this one should be 9. So it has also something to do with, I think this one should be 9. Yep. So it also has something to do with the difference between the two. Maybe I should calculate the difference between the two. Or we can just be dumb. Because they either choose move this, right? There are only so many choices. You move here, move these two, or move these two. That's it, right? Because we can only move 2, right? We can only move 2. And then these are the only options. You move front and back, which is this, right? You move 2 from the front, or you move 2 from the back, which means what we shall get is the minimum of this. That's 1 front and 1 back. Or we say 2 from the front. That has nums -1 minus nums 2. Right? 0, 1, 2. Or you can say move 2 from the front. No, 2 from the back. That's nums -3. Right? Minus nums 0. That, my friend, I think is the solution. Yep. Try it. There we go. It's good that we run some test cases. Yeah, always try to imagine you're doing it, right, in the actual contest. Try assort nums and try all possible modifications. Either we change, right, we change the smallest and largest to the second smallest and second largest, right? Or we change the smallest and second smallest to the third smallest, oh my god, or we change the largest and second largest to the third largest. No other change can make no other change makes sense, and no other changes need to be considered. All I have to say when I log in. Okay, what do people say? With or without sorting? Oh, we can do ON. Are you kidding me? Are you kidding me? You're literally, you're finding the, oh my god. Finding the 3 smallest and the 3 largest. You gotta be kidding me. No. I do not think I will approve of this thing. Could have been, sorting is very fast. Yeah. I don't think this is worth it. I mean, it is ON, right? You have to give it to that, but I think I like this, right? I like this. Okay, I don't know why people don't like this one. It's fun. Okay, next one, minimum possible or. Okay, you're given a 0 index nums. We say that integer x is expressible from nums if there exists some integer for which this or this, so the or equals x. We say an integer x expressible if we can pick some numbers from nums and OR them together. In other words, an integer is expressible if it can be written as the bitwise OR of some subsequence of, okay, that makes sense. Return the minimum possible non-zero integer that is what? Not expressible by nums. Non-zero, so 1. 1 is fine, 2 is fine, 3. So 4 is a num. Okay. So it's a subsequence. All right. I'm gonna pick subsequence or everything, and we want to find out what's the smallest non-positive integer that it cannot do. If we're given a integer, can we tell if it can or cannot be done? That's a very good question. I have no clue. I mean, for one thing, we can get a set of everything, because repeated numbers don't mean anything. So we only need to consider the unique ones. Okay, we're gonna consider the unique ones. And then what? Well, or only makes the value bigger, right? It gave me 2 values. They only makes bigger because 101 is 1, right? They don't change. 100 is 1, so they actually make things bigger. So what I'm saying is a small value, a large value, hold on. 2 value, the OR of 2 values is always bigger, okay? Always bigger. So therefore, I think you can just sort it. You sort the values and just find the smallest non-positive, a non-zero integer that's not existing in the sorting. Yeah. I mean, if there exists like this one, right? You have 2, 3, 5. We know all of any of these will be bigger than 2, 3, 5. So we just find the first missing one. Now in this case, 1 is the first missing one. So we can sort it and go through that, right? Which also means if we sort this and then we go from 1, 2, 3, 4, right? We keep going. The first one that's missing is going to be the result. But the problem is, what if it's like this case, right? If it's this case, you have 1, 2, 3, 4, 5, like all the way down. Then what is the smallest that it cannot be formed? I honestly have no clue. Isn't the smallest just the first one or the last one? Right? Because everything else, if you OR everything else, if it's 1, you OR the last one, it might be the same. It might not be the same. That's okay. So we can just try from the largest one, we OR 1 and see if there's anything that's missing. And you OR 2. Huh. Hold on, let me think again. Yeah, if the last one has 0 at the end, then we OR 1, it will become something bigger. Then boom, that's the result. Right? We don't have to worry. And that's not the result. That's just the next possible OR. So that one plus 1. No, you do not know. Holy crap. You do not know. So we need to know the hold on. All right, let's summarize. If we have a missing value after we sort, that the first missing value is the result, right? We can agree on that. If not, we have a whole thing, right? 1, 2, 3, 4, all the way to k, okay? Then how do we know which one? Well, what we know is we shall be able to, right, whatever it is, if it's a consecutive, then we shall be able to find something to make it into 1, 1, 1, 1, 1, right? That's, I think, is a given. Because all these values are smaller than it, so we can always find one to make it work. Therefore, the smallest will be whatever the k is represented, is that thing, or 1 plus 1. So in this case, right, 2 is 1, 0, right? So the largest, so it's a 2 position. So largest of 2 positions, 2 bits is 1, 1. So the result is 1, 1 plus 1. That makes sense. That absolutely makes sense to me. Okay, let's do this. So here is my idea. First of all, we sort. Wow, they all sort. We all sort from the front. Okay. Right. Then what do we say? We say, how do we find a first that's missing? You can always, rotate and stuff. But I already sorted, so I want to find the easiest way to write. The first one that's mismatching, right? The first one is mismatching. For I, n in enumerate nums, right? If I plus 1 is not equal to n, I plus 1 is not equal to n, then return I plus 1. That's the one. Unless it's the last one. Hold on, let me think about the last one. What if the last one? Yeah, it's still I plus 1, right? That's still the last one if you mess with it. Otherwise, which means everybody is good, then you need to look at the last one, which is nums minus 1, right? You need to know, need to binary it, okay? Now you binary it, you take from the second to the last, you get its length, so you know how many digits it is. Then you say 1 left shift this much, right? 1 left shift 2. How much is 1 left shift 2? 1, 2. 1 left shift 2 is 4, right? 1 left shift 2. Yeah. Oh, so we just return this? Try this now. Yeah, it was a terrible one this time. Okay. Then I say 1, 2, 3, 4, 5. Okay, I should do this. I actually should do this. Alright? And I think this one will be wrong. This one will be wrong. Oh, I have a... Jesus. Yeah, this will be wrong because I'll say, this is wrong. So I need to set. Yep, that is wrong, but it's easy to solve. I can just say sorted uniques equals sorted set nums, and this will turn to sorted uniques, and this is also sorted uniques. That shall be right. There we go. Have you tried only one? Shall be good. Yep. 走你. Oh, Lord. What the hell? Oh my God, this is correct. Yeah. That was too confident. This is right. Should be 4. Oh my goodness. Small change. We just need small change. A small change. Oh wow. We shall result. Right, result. So if it's not equal to n, okay, so we find something. Yeah, so we go and then we find the first one that's not equal to n, right? Which means that is a gap. Now when you find this gap, you need to get the current biggest one, which we can get, right? We know which one is the missing one, right? We know which one is the missing one. Oh, how should we do that? So we have all the consecutives, right? And then boom, we have a missing one. Then we shall know what is the current thing that's not cannot be made possible, right? Cannot be made possible. Or we should do the thing that can be made, the largest thing that can be made possible. We should do that, right? And then we go to the next one and see if the difference, right? See if the difference, yeah, that's what we need to do. That's what we need to do. So I need to change this a little bit. So I need to change this a little bit. So pre, okay? Pre is 0. Pre is 0. How about just say for n in sorted uniques? Okay? And then I say if n minus pre is equal to 1, everything is good, right? But if minus is not equal to 1, right? If it's larger than 1, right? That means the n is going to be a break. Now, what we need to do is, we also cannot go forward. That'll be easier. Let's do this way. Smaller than len sorted uniques. Oh, this is actually a good question, right? And we say if sorted uniques I is larger than 1. But if it's smaller than 1, then we just let's do else first. So else, which means it's equal to 1, right? It's either equal to 1 or larger than 1. If it's equal to 1, then we just do pre is equal to sorted uniques I, right? And then I plus equal 1. If it's larger than 1, then we don't increment I, but we will redo pre. So pre will equal to this, right? Pre will equal to this. If it's larger than 1, right? So we have a break. So we reset the pre, and then we'll come back again, right? We'll come back again. If it's still, no, we do not come back again. We set the pre, right? We set the pre, and then this is actually just going to be I, right? So this is going to be just the maximum value we can get up until this point. We do the pre. And if, right, and then we just say if this is, right, and then we do it one more time. We say if sorted unique I minus pre is equal to 1, right, then pre will equal to this, so we move forward. Else we'll return pre. Okay, what if we go all the way to the end? Well, if we go all the way to the end, everything is this, then at the end we will have to return this. This is actually still useful. What the hell, man? That's neither here nor there. I do not like it. Do not like it at all. Like, what the hell, man? What the hell? Print sorted I 1 0 2 1. What? Now we go to 25. Holy crap. That ain't I. It should be I minus 1. Because it's the current I, yeah, it should be I minus 1. It should be pre. Dear Lord. It should be pre. That should be pre. Because the current one is larger than pre, right? So we have to do pre. And this is the max, so we reset the pre, right? And then we do it again. Pre plus 1, yes, that's correct. Pre plus 1. Okay. Let's try this. And I have to add this one as well. Oh, that was bad. Oh, that was pretty bad. Hold on. 5 3 2. 5 3 2 and 5 3 2 should be 1. Okay, so we start. So the first one's wrong, right? First one is 2. 2 minus that's larger than 1. So I say pre shall equal to pre is 0, right? Come on, man. Huh. So pre become 1. How is that possible? You are at 0. You are at 0. You cannot make... Dude. You are at 0. You only have 0. Oh, hold on. You are only at... You are 0, right? If you are 0, if pre is 0, that shall be a different situation. If pre is 0, and you're saying I have value, which is 0 by itself, right? What's the maximum you can make? And you cannot make it to 1. You cannot. Right? So that actually have to be this. Let's say times pre is equal to 0 and not equal to 0. It has to be not equal to 0. If pre is 0, then yeah, there's no chance. Can't do it. Right? Cannot do it. If it's 1, if pre is 1, okay, like 1 3. 1 3 is also not going to work. Alright, if we go 1 3, you have 1, alright, and then go to 3, and you say what is the maximum we can make? Because it's only one value, man. One value. You cannot do anything. 1 2 is the first time you can do something. 1 by itself you cannot do anything. So we shall say not equal to 0 and pre not equal to 1. Okay, so this is what I think pre 0 and 1 is like different case. If it's 1, the max we can make is going to be 1. Basically, we just say we do not change. Yeah, I might as well just put it here. If this and pre is not equal to 0 and pre is not equal to 1. Right? If pre is equal to 0, then boom, we don't do it. we just keep going. If pre is equal to 1, we also don't do it. And we can try a test case. We can say 1, 3, 4, 5, 6, right? Try that. Yep. Wanna rock and roll? Yeah, let's rock and roll again. Oh, we are hitting one of those problems. One of those trial and error problems. Damn. Why would I put 8? Didn't make any sense. I have an 8 in it. Dear Lord. Alright, we have 2 errors. Right? 1, 2. We can make all the way to 4. Ah, God. So pre is 4. It should be smaller or equal to. Yeah, should be smaller or equal to. Minus pre. So the pre can be big, right? The pre might be big, but as long as it covers, then we don't really care. I think, hold on. If this minus the pre is smaller or equal to 1, so the pre could be big, right? So it might be a negative value. Then do you really if it's smaller or equal to 1, and we shall only change if if it catches up, right? Which means if sorted uniques, right? And we'll only change. So if sorted uniques I minus pre is equal to 1, when that happens, then we update. Which means sorted unique I is bigger than pre. Then we need to update. Otherwise, we don't even update pre. Okay? We don't even update pre. Okay. This is correct. How about the others? They're all correct. Alright, one more time. One more time. Let's hope this time it works. Oh my God. Does not work. The last one. One, 3, 4, 5, 6. Answer shall be 2. Dear Lord. 1, pre is 0. Okay. How pre is still 0? It's equal to 1. I don't understand. This is 1. This is 0. 1 minus 0 small equal to 1. 1 minus 0 equal to 1. Pre shall equal to 1. And then we'll come back up. Pre is 1, right? Now is 3. Oh, I didn't do this. I didn't do the check. Wait, why did I not do the check? I have no clue, man. I have no clue why I did not do this check. I thought I did it. Thought I did. What would you say? I always say this is update pre, right? So I always say this is update pre when a consecutive subarray ends. Okay. Okay, they're all good. I have these test cases. They are all good as well. Okay, now one more time. This time we got it. Dang, look at the runtime. Bad. All right, this one deserves tomorrow. We need to take a look again. But yeah, I only want to do this much. Time to go to bed. Okay, so how would you do this? How would you say? I would say, right? We'll say, well, sort nums first. Sort unique, right? Unique nums first. Oh, maybe in this case we don't even have to sort unique. Maybe we can just do. Let's try it. Sorted nums. Now we can just say nums.sort. Okay. Yeah, it will work as well. They all work. They all works. Yeah. So we say sort nums first, right? Then for any break in consecutive, any break in non-consecutive, any break in consecutive consecutively increasing subarray. Any break, for any instance where nums I is minus nums I minus 1 is larger than 1, we can compute the largest possible integers that can be formed by all the consecutive values up to nums I minus 1. All right. Which is the value of the same binary size as nums I minus 1, but with all positions being 1. Then we check, right, if this largest possible value, ORed value, can continue the consecutive trend with nums I, right? If I can, we keep going, right? If not, then we have found the answer. Open login. So this is kind of solution 2. So we don't have to do unique. Try this. Slightly faster. Okay. So that's 1 hour. Okay. What the hell did you do, man? I copy this. Alright, I'll see you guys tomorrow. And I'll read the solutions for this. Adios.